What's up, guys? This video is going to cover the honeycomb activity. I'm going to show one or two ways to do it and describe how you might try others as well. So we did the hexagon, which was something like this. We're going to do 6 lines and also 6 turns. So we're going to go forward some amount. I'm going to choose 50, but it could be anything. And I'm going to turn left 60, because the whole thing, if we're going back to where we started, is 360. If we were doing a square, we divide it by 4 and turn 90 each time, but we're doing a hexagon, so we're going to divide it by 6 and turn 60 each time. So if I run that, I get a hexagon. And the goal for this is to surround it with one layer of other hexagons to make a honeycomb. Now, when I've shown people how to do this, usually they start with one at a time. So they'll go to a place, do the hexagon, go to another place, do the hexagon. And that's fine, but I want to show that you can build it into a double loop and connect one to an arm of the original, and then the next one to an arm of the original as we go around. So if we imagine another hexagon, I'm going to say J for the second loop, just because if we use I twice it might get mixed up. And then I'm going to say, what if we go forward, and you imagine going and turning around this way, and then this way, and then going around, which means instead of left we're going to go right. And I'm going to play it. This is on the slow speed. I haven't bumped the speed up yet, so you'll see it go around, which is that every time it does an arm, it goes around to the right and then goes back around to the left for the interior hexagon. And now we've done a lot of stuff in only 6 lines of code. So if I were doing this a little bit nicer, I would give this a name, and then I would call that function to do its job. And this is going to have the same result, but it looks nice. This is labeled, and if we had a program that needed to call honeycomb multiple times, well, now we could do it with the name and everything would be in order. However, since we did that, we've learned another way to make a hexagon. So I'm going to show an alternate way to do it, which is we have this thing built into our circle function. Imagine we were going to do a circle. Okay, this is not going to look good at all. This is not going to make any sense. But imagine we did a circle at each point in our hexagon. We would go around, do a big one, loop, loop, loop. Now the thing is, there are alternate circles that you can parameterize. You can add more parameters to say, oh, go only halfway around, or break it up into this many steps. And so if we say steps equals 6, then it's going to make a hexagon at every point. Now again, they're not lined up yet. They're not turned at the right angle. In fact, they're not even the right size. I should have put 50 there. But if we can take this and just tilt them outward, then it's going to do the same job of the honeycomb. So our goal here is to turn a certain amount. Well, we're already turning a little bit, so we can kind of build it into there, and then turn back the other way. I think what we need is a difference of 60. Like if we turn left some, turn right some, and there's a difference of 60, it'll add up. And I think what it is, I tested this earlier, I think what we need is 150 and 90. Let me test that out. Yeah, that looks good, right? So what we're doing is we're turning inward and then doing the hexagon outward, and then we turn inward and do the hexagon outward, just like we did a minute ago, except using a different method. The circle function knows how to do other types of things like half circles, it knows how to do squares, it knows how to do any type of regular polygon. You just have to tilt it to the right angle. So is that better? Not really. Is it shorter? Yeah, it's 1 line shorter. But the idea is just to show that there are always creative approaches, and when you learn something new, you can go back to the old activities and try them in different ways and see what you think. The honeycomb is meant to use loops, but it can use other things as well to get the job done. Thanks.